You can hold cryptocurrency in a digital wallet. You can send it across the world without touching a bank branch. You can see numbers move on a screen in seconds. So it is easy to think crypto is completely virtual. But behind some of the biggest cryptocurrencies is a very physical system. Warehouses full of machines, power lines, cooling fans, internet connections, mining pools, electrical infrastructure, and thousands of computers competing every second to secure a network. That hidden system is cryptocurrency mining. But what is it actually doing? Why does it use so much electricity? Why do miners need giant facilities instead of ordinary laptops? And how does all of that turn into new blocks on a blockchain? To understand it, we need to separate the digital idea from the physical infrastructure behind it. First, not all cryptocurrencies are mined. Some networks use different systems. Ethereum, for example, no longer uses mining after switching to proof of stake. But Bitcoin, the best-known cryptocurrency, still uses mining through a system called proof of work. That is the version we are focusing on here because it is where the most visible mining infrastructure exists. The basic idea sounds strange at first. Bitcoin miners are not digging coins out of the ground. They are using computers to compete in a global guessing game. That game helps decide who gets to add the next block of transactions to the blockchain. A blockchain is a public record. It is like a shared ledger that keeps track of transactions. Instead of one central company controlling the ledger, thousands of computers around the world help maintain it. Transactions are grouped into blocks. Each new block is linked to the one before it. That creates a chain of records that becomes extremely difficult to change. Mining is the process that adds new blocks to that chain. Here is the simple version. Miners collect pending transactions. They organize them into a candidate block. Then their machines try to find a special number that makes the block fit the rules of the network. This involves running a cryptographic function over and over again. The miner is not solving a puzzle through intelligence. It is more like trying billions or trillions of guesses until one works. The first miner to find a valid answer gets to propose the next block. If the rest of the network verifies that the block follows the rules, the block is accepted. The miner receives a reward. That reward includes newly issued Bitcoin and transaction fees. This is why mining exists. It gives miners a financial reason to spend electricity and computing power to secure the network. Now, the important thing is that mining is competitive. Every miner in the world is trying to find the next valid block. Only one wins each round, and Bitcoin is designed so that, on average, a new block is added about every 10 minutes. But what happens if more miners join the network? More machines means more guesses. More guesses could make blocks appear too quickly. Bitcoin handles this through something called the difficulty adjustment. Roughly every 2016 blocks, which is about every 2 weeks, the network adjusts how hard the mining puzzle is. If blocks were found too quickly, the difficulty rises. If blocks were found too slowly, the difficulty falls. This keeps the system aiming toward that roughly 10-minute rhythm, even as mining power changes around the world. This is one of the most important hidden mechanisms in Bitcoin. The network automatically adjusts to the amount of computing power competing for blocks. Now let's look at the machines doing all this work. In Bitcoin's early days, people could mine using ordinary computers. Then miners moved to graphics cards. Today, serious Bitcoin mining is mostly done with specialized machines called ASICs. ASIC stands for Application-Specific Integrated Circuit. That just means the machine is built for one job. In this case, that job is Bitcoin mining. ASIC miners are extremely fast at performing the specific calculations Bitcoin mining requires, but they are also power hungry. They produce a lot of heat and they are loud. A large mining facility can sound like a room full of industrial fans, because heat management is one of the biggest challenges in the entire system. This is where mining becomes real infrastructure. A mining operation is not just a few computers on a desk. It may involve rows of ASIC miners stacked in racks, electrical panels feeding huge amounts of power, transformers, ventilation systems, cooling fans, network equipment, monitoring software. technicians, and careful planning around energy cost. Electricity is one of the biggest expenses in mining. That is why miners care so much about location. A mining facility is often built where electricity is cheaper, more available, or easier to contract. Some operations are near hydroelectric power, others use grid power, some locate near energy that might otherwise be wasted or difficult to transport. The economics are simple. A miner earns revenue from block rewards and transaction fees, but pays for machines, electricity, cooling, maintenance, rent, and staff. If the cost of mining is higher than the revenue, the operation loses money. That is why mining is both a technical system and a business. The machines are constantly competing, but the businesses behind them are also competing to operate more efficiently. Cooling is another major part of the infrastructure. ASIC miners create heat as they run. Too much heat can reduce performance, damage equipment, or shorten machine life. So mining facilities are designed to move heat away quickly. Some use massive air cooling systems. Fans pull cool air in, push hot air out, and keep airflow moving through rows of machines. Other facilities use immersion cooling. In immersion cooling, mining machines are placed in a special non-conductive liquid that absorbs heat. The liquid does not damage the electronics because it does not conduct electricity. This can reduce noise and help manage heat more efficiently, but it adds complexity and cost. The cooling design depends on the climate, energy price, building layout, and scale of the operation. A mining site in a cold region faces different challenges than one in a hot climate. Now let's talk about mining pools. Most individual miners do not mine completely alone. That is because the odds of one small miner finding a block by itself are very low. So miners often join mining pools. A mining pool combines the computing power of many miners. If the pool finds a block, the reward is shared among participants based on how much work they contributed. This makes payouts more predictable. Instead of waiting a very long time and hoping to win alone, miners receive smaller but more regular payments. Mining pools are important because they show another layer of infrastructure. The mining hardware may be physical, but coordination happens through software networks. Machines connect to pool servers. They receive work. They submit results. The pool tracks contributions and distributes rewards. So cryptocurrency mining is not only hardware. It is hardware plus software plus networking plus energy systems. Now, because mining is competitive, speed and uptime matter. A mining machine that is offline earns nothing. A facility with poor cooling may lose efficiency. A site with unreliable electricity may miss opportunities. So mining operators monitor everything: machine temperature, hash rate, power use, fan speed, internet connection, revenue, difficulty, Bitcoin price. Even small changes can affect profitability. This is why modern mining facilities often look more like industrial operations than hobby computer rooms. They are optimized for constant performance. One of the most debated parts of cryptocurrency mining is energy use. Bitcoin mining uses electricity because proof of work is intentionally costly. The cost is part of the security model. To attack the network, someone would need enormous computing power and electricity. That makes attacks expensive. Supporters argue that this energy use helps secure a decentralized financial network. Critics argue that the electricity demand can be large and should be carefully examined, especially depending on the energy source. Both points are part of the real conversation. The important thing for this video is to understand why the energy use exists. It is not accidental. It comes from the proof-of-work design. The network uses competition, electricity, and computation to make rewriting history extremely difficult. Now, mining also affects local infrastructure. A large mining facility can place significant demand on the electric grid. That may require upgrades to substations, transformers, transmission lines, or power contracts. In some places, mining has raised concerns about grid stress, emissions, noise, and local electricity prices. In other places, mining operators argue they can help use excess energy or provide flexible demand by shutting down during grid stress. This depends heavily on the location and how the mining operation is connected to the energy system. Again, the story is not one simple answer, it is infrastructure. And infrastructure always depends on design, location, and management. Another thing people often misunderstand is what miners are actually protecting. Miners do not approve transactions because they like them. They follow network rules. If a miner tries to add an invalid block, other nodes reject it. Nodes are computers that verify the blockchain rules. Mining proposes blocks. Nodes verify them. That distinction matters. The system depends on both miners and nodes. Miners provide proof of work. Nodes enforce the rules. Together, they help keep the network decentralized. Now let's follow a Bitcoin transaction through the mining process. You send Bitcoin to someone else. That transaction is broadcast to the network. It waits with other pending transactions in an area often called the mempool. Miners choose transactions from this pool, usually prioritizing those with higher fees. They build a candidate block. Their ASIC machines start hashing, trying to find a valid result. Across the world, other miners are doing the same thing. Eventually, one miner finds a valid block. That block is broadcast to the network. Nodes check it. If it follows the rules, it becomes part of the blockchain. Then miners start competing for the next block. From a user's perspective, this may look like a transaction slowly gaining confirmations. Behind the scenes, it is a global race of machines, electricity, cooling, and networking. That is the hidden infrastructure behind cryptocurrency mining. The digital ledger is visible online, but the work behind it is physical. Machines convert electricity into computation. Cooling systems remove heat. Networks coordinate miners. Pools organize rewards. Power systems keep everything running. And software rules decide what counts as valid. Cryptocurrency mining is often described as abstract, but it is one of the most physical parts of the digital economy. It turns energy, hardware, and infrastructure into network security. Whether someone sees that as brilliant, wasteful, or somewhere in between, the mechanics are important to understand, because every mined block depends on real-world systems: buildings, machines, electricity, cooling, internet connections, and people maintaining it all. The next time you hear about crypto mining, remember that it is not happening in some invisible cloud. It is happening in industrial spaces filled with specialized machines, running constantly, competing with machines all over the world. That is the infrastructure behind cryptocurrency mining. And like many hidden systems, the better it works, the easier it is to forget how much has to happen behind the screen. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.